Welcome to this demonstration of TIM and the power of instant machine learning. Today we would like to talk about a new approach in time series analytics. TIM, the Tangent Information Modeler, is a time series model building strategy which you can leverage to quickly and effectively build predictive models. This new technology is comprised of different components which combine unique mathematics with the flexibility of data platforms to transform time series data into actionable insights and results in a matter of seconds. At the core of our solution is the TIM engine. This is where the innovation of using information geometry for time series analytics takes place. The engine is wrapped in an API which allows you to efficiently communicate with other platforms. On top of the API, we have created the TIM Studio, which is a web app that allows you to experiment and explore your time series data and get a sense of the capabilities of the TIM engine from an easy-to-use web interface. You can also use our TIM clients to focus on automating, scaling, and most importantly, operationalize your time series experiments. Now, to give you some idea about the secret sauce behind all of this and talk about what happens at the core of the engine, well, there are two big steps that need to take place to actually transform raw time series data into actionable insights and results. First and most importantly, good feature engineering is a crucial step in extracting predictive value from your data. Secondly, efficient model building is needed to bring together the right features into a useful model. For the feature engineering, we uniquely use information geometry, and what that allows you to do is to reduce the training time of models to a matter of seconds to minutes. That speed in turn opens up the possibility to tackle large-scale use cases. We start from raw predictor inputs variables, which we included into the dataset. From there, a feature expansion phase takes place, where we go through all of these columns and create thousands of potential features, thousands of potential predictive patterns that may exist in the data. We plot those features into a multi-dimensional space, and from there we make a selection using Bayesian information criterion to select those which explain the variance of the variable which we are looking to model the most. Once we have identified those features, we can bring them together into a GAM model, a generalized additive model, which is a linear model which we optimize using a specifically designed algorithm. And from there, we have a human-readable model which we can now leverage to make predictions. This all takes place within TIM and requires no effort from the user. TIM takes away most of the complexities in time series modeling and automatically delivers high-quality prediction models. Let's show you this in action. Next, we'll show exactly how this can be done in the TIM Studio. First, let's have a look at the API. Here in our Swagger page, you can access all the endpoints that we have made available to communicate with TIM. There's a whole range of endpoints that allow you to organize your work and experiments to enable machine learning operations and effectively tackle time series use cases. Furthermore, we have ways to upload, update, and manage your datasets to make sure that you have the best data available while building models and generating predictions. Lastly, we have different endpoints for different forecasting or detection capabilities. Now on top of this, you can integrate this API with different platforms to bring advanced time series analytics to the end user. We're going to show you a first example of this in the TIM Studio. To get access, visit the TIM Platform TangentWorks web app, log in using your license credentials, and from there you can either use our example templates or upload your own datasets to quickly get started. We'll have a look at this example dataset with which we want to forecast energy consumption in Belgium. Here it's visualized with this particular variable called quantity. In order to accurately model this variable, we want to augment our dataset with predictor candidates. In this example, we have included weather observation and forecast data such as temperature. Here in the studio, you can easily explore your data and visualize the different variables on the same scale to get an idea of the predictive patterns that exist within the data. These are the patterns which we want TIM to automatically detect for us. Have a look at the other variables as well. The objective here is to include any variable into your dataset which might have predictive value. From there, TIM will automatically extract that value and build the model from raw inputs. Once we are happy with our dataset, we can think about how to apply TIM. For this, we'll move to the configuration on the right. Here we can describe to TIM what kind of model to build. For example, we have uploaded an hourly sample dataset which Tim automatically recognized. With this, we can do a day-ahead forecast by setting the prediction horizon to the next 24 samples. Now Tim is designed to automate as much as possible, so while we do have a wide range of potential settings that you can use to optimize and adapt Tim to particular cases, you can use the automatic mode. With these default settings, Tim decides for you what kind of features to build from the model to get the best possible forecast based on what it learns in the data. We have our dataset, we have our configuration. We are now ready to build a model. By clicking on Forecast, we send a request to the API. It will now start calculating, and as we see the progress bar move forward, the two steps of feature engineering and model building take place within the engine. Tim is going through each of the variables in our dataset and applying all sorts of mathematical transformations to them to find predictive patterns. Think of offsets, moving averages, calendar information, cyclical patterns, and so on. This generates thousands of potential features which are analyzed using information geometry. From all those features, a subset is selected based on how much of the variance of our target value they can explain. These are then brought together into the GAM model which we can inspect shortly. The model is now ready, and several outputs are returned from Tim. Firstly, we can have a closer look at the predictions. The Tim Studio will automatically do a backtest to validate the quality of your predictions. Here we see that both the in-sample training and the out-of-sample testing results align quite closely with the actual values of our variable. That already gives us a visual confirmation that the model will likely create high-quality day-ahead forecasts. We can also calculate different KPIs to determine the accuracy. Tim automatically returns both in and out-of-sample results for the metrics below. For example, the out-of-sample mean absolute percentage error is about 2.5%, which roughly translates to 97.5% accuracy of our predictions. If we now want to learn from Tim exactly how these predictions were calculated, we can have a closer look at the model. We open up the Model Zoo browser on the right, and here we can gain several levels of insights into the data. First of all, the predictor importances show us which variables were used by Tim to generate features, and you can see their relative impact in the model. In addition, you also receive a list of variables which have been excluded from the model. This can already provide you with valuable information. Imagine having a dataset with hundreds of variables with potential predictive value. Here, Tim can guide you towards those that actually have an impact in your use case. Next, we can go one level beyond and have a look at the actual models that Tim has created for us. In this visual, we can learn which features Tim calculated and selected from thousands of potential predictive patterns and see their relative impact in the model. You can see different offsets of several predictors appear in this model, as well as calendar information like the days of the week. Certain moving averages and thresholds in certain predictors also appear to have predictive value in this case. Most of these features are also combinations of other features to capture interactive patterns between the variables. As you can recognize, quite a complex model has been generated directly from the data with Tim in a very short amount of training time. To go through all of these possible features seems like an impossible task to do manually, and this is how Tim can show you the actual specific patterns that exist within the data. Now interestingly, here we did not build one model, we actually built 24 models. We asked Tim to forecast 24 samples ahead, and by default Tim will build a unique model for each sample in the horizon. So the model to forecast values for 4 a.m. looks like this. The one for 9 a.m. looks like this one. For 3 p.m. it looks like this. And this approach is proven to be quite useful in extracting a lot of accuracy from the data because different patterns might exist at different hours. Different horizons further ahead might be faced with more uncertainty, and you want to capture that in specific models. This is actually the standard approach of Tim, and this is where our model building strategy really becomes very competitive on accuracy. All these models are GAM models which were calculated just now. Here you can also see the mathematical formula by visualizing them as a table. We see the different features listed and their respective coefficients. By multiplying the feature values with their coefficients and summing up all of those results, you can calculate the predictions we saw in the graph earlier. Those are in a nutshell the outputs that Tim generates on the fly when it's building a forecasting model. From here we can actually do quite a lot more. There's plenty of other capabilities available in the studio to further explore your time series data. We can iterate a new experiment, start optimizing by either changing the mathematical settings, or maybe include more variables with predictive value that we want to explore. If we want to operationalize this, Tim users typically move towards the Tim clients to really start transforming their time series data into predictions at scale and transform predictive value into business value. To showcase this, we will now use Tim through our Python client. Now, to get started on the Python client, we need to install the Tim client library, which allows us to effectively communicate with the API through Python. You can visit PyPy and install the Tim client's latest version. To help you get started, we have created example templates for all of the different capabilities of Tim. Visit our GitHub page to get access to the templates and use our example datasets to get familiar with Tim in Python. These files can be quickly adapted to your own specific use cases, so you can start building time series models in no time. Now, to show you this in action, we can download this particular template where we will build a quick forecasting model. Here we first want to import the different libraries needed to run these notebooks and visualize the insights that we will get from Tim. We will then also want to import the Python client as a library and activate it using our credentials, and then we're ready to start building models. First, let's prepare the data we want to analyze. Included with the template is data from the same use case we previously tackled in the studio. We can import this data as a CSV file into a Pandas data frame and pre-process it so it's ready for Tim using this sample code. If we visualize the data frame, we can see the hourly timestamp, the target value quantity for which we want to build a forecasting model, and the predictors which we will use to augment our analysis. Also here, we like to visualize the data to get an understanding of the predictive patterns which exist within. For this, you can use the sample visualization code in the template. Next, we can create the configuration to tell Tim how to analyze this dataset. As you can see, plenty of settings exist which allow you to remain adaptable to the many kinds of use cases which exist in time series analysis. Luckily, also here, Tim can run on automatic mode. When not specified in the configuration, Tim will assume the default settings and decide for you if these different kinds of features are to be included in the model. In this case, we will ask Tim to also do a 24 sample ahead forecast. In addition, we will specify to Tim to exclude a number of rows from the end of the dataset from the training process and use those rows for testing. This way, we can also do a backtest here in Python. This creates a JSON configuration which we will send together with the dataset to Tim. Now the work of Tim can start. You can organize your work within the Tim platform and specify the workspace in which you want to upload the data and build the models. Lastly, we can use the quick forecast function to send the request from this notebook to our API. This function combines the work of several endpoints together and allows you to upload the data to Tim and immediately build a model. It only requires our data frame and configuration as an input, and from there we can choose what it returns. Once the model is finished, this function will collect a range of results and insights from the API so we can continue post-processing the results in this notebook. Let's send the request. First, the dataset gets uploaded to Tim. The dataset remains within the platform, which means that after this experiment, the dataset can be reused or updated with new data points later. Secondly, the model is built immediately after the data upload. This allows for quick experimenting on new data. We can see the live status of the model building job progressing. Tim is now calculating the features from the raw input data. Once that is complete, the most useful features are combined into the GAM models. The quick forecast method will then return several responses about the data upload process, the model building process, and workflow management from the API. As you can see from the status, building a time series model with Tim will only take seconds to minutes, will happen automatically, and can be done without having to worry about the many complexities of time series analytics. Instead, we can focus on using the results, which is what we can do next. The model build job is now complete, and the work of Tim is done. The function collects all outputs from Tim into our notebook, and we can start post-processing the results. For this, you can reuse the sample code of this template, which will transform TIM outputs into useful data frames. These can then be used to visualize the results and insights. In this visual, we see the in-sample training and out-of-sample testing results visualized in green and red respectively on top of the target variable. We have also visualized the absolute error over time to quickly find the periods which are harder to forecast. With this template can quickly assist you in optimizing the models and get to the best possible predictions. You can further inspect the predictions in the graph or move down to other insights, such as the accuracy metrics and model importances. Here we can see both the in and out of sample accuracy expressed with different KPI metrics and on different levels. If you want to know the overall accuracy or inspect the accuracy of individual models in the multi-horizon forecasting model of TIM, this is where you will find your answer. Next, we can learn about the patterns in the data that have been detected by TIM. On a first level of insights, we can see the predictor importances and see in which variables predictive value was found and which were excluded automatically by TIM. On the second level, we visualize the feature importances in this sunburst diagram. This allows us to quickly browse the individual models and learn what patterns are used to forecast a different number of samples ahead. For example, the model for forecasting one sample ahead contains these particular features. Again, a complex model with a wide range of different kinds of features has been automatically created by TIM in a matter of seconds. Lastly, if you want to learn more about the job execution, you will find the right information in the job logs. Any warnings or items of interest which TIM recognized in the data are listed here. This concludes the quick forecast template. Save the results for later reference and try out the other templates to get familiar with the many capabilities of TIM. Combining the flexibility of working in a Python environment with the unique analytics of TIM allows you to tackle the many kinds of use cases which exist in time series. TIM is use case agnostic, so you can easily adapt this template to try out TIM on your own data using the same forecasting process. Also, the fast mathematics of information geometry allow you to tackle large volume, high frequency, and large-scale cases. Using the other templates available, you can quickly set up a data pipeline in production and use the parallel processing capabilities of TIM to replicate this forecasting process 1,000-fold. The user doesn't have to worry about managing and deploying the models. The models and the results all exist within TIM by default and can be accessed referring to unique IDs which you receive after running model building jobs. This facilitates machine learning operations and gets you to business value much quicker. With this, you have all you need to get started with TIM. If you either want to explore your time series data in the TIM Studio or tackle complex cases with the Python client, TIM will accelerate your work with time series data significantly. To get access to TIM, go to tim.tangent.works and get started with a free trial. For more content, check out our website and YouTube channel. We hope to hear from you in case you want to learn more about TIM and its new approach to time series analytics.